So first off, what questions do you guys have from the Part B calculations? Yeah. Never mind. Trying to figure out how to know what? No? Yes? No? Okay. Or people can come up to me and I can answer them, whichever.
C says 2 and then...
Yeah, so I can actually go through and show you some of these. Okay. So, do you want to take this back? I have some copies of it.
For this part, how do we choose which ones to add?
Okay, I can go through that too. Yeah. All right. Cool. So I got 2 questions that you guys want clarified. The first question, gentlemen, I'm glad you're trying to help each other, but I'm trying to also help everybody. So if you still don't get it after I explain it, then help each other. Okay. All right, so I've had 2 questions. The first question was regarding the ratio section. So when we get to here and we're looking at figuring out, how much we need of acid versus base for the neutralization to occur. So in this example that I gave you guys as a teaching example, which is on the yellow piece of paper, it was a 1-to-2 ratio, and we are starting with the acid and going to the base. So in that case, I multiplied by 2 to figure out how much base I need. It is going to depend on what the question is asking you. So for the first question in your green paper, you had the sulfuric acid, and you have the sodium hydroxide. In this case, it was 1 mole of the sulfuric acid to 2 moles of the sodium hydroxide. In this question, you were starting with the sulfuric acid, so whatever your sulfuric acid is in this case, you will be multiplying by 2 to get the moles for the base. So think about it in reference to what's happening in your equation. Are you okay so far? Next one? Okay. So in question number 2, again, we are looking at the numbers in front. In this case, we have a 1 for, what type of acid is that? Citric acid. And that ratio is 3 sodium hydroxides. So for every 1 citric acid, I need 3 times as much sodium hydroxide to neutralize it. So again, we take this value that we have here, and because this is a 1-to-3 ratio, we're going to multiply by 3. So we will give you the equations. You do not need to have those equations. Are we good? All right. Number 3. All right, this case, we're looking at the sodium hydroxide, and we're looking at, which acid is that now? Oxalic acid. Unfortunately, I probably should have put it the other way around in the equation, but that's okay. So for 1 oxalic acid, I'm going to need 2 sodium hydroxides. So again, figure out what your acid amount is. Since this is going to require twice as much, we're going to times it by 2. Okay? If the number was the other way around, say, for example, actually, I can't think of an example off the top of my head where a base has got multiple things. I keep grabbing purple. All right, so let's say, for example, if we had something that had, let's say we had something that was 2 acid and 1 base. So what this tells me in this ratio is that the base is stronger than the acid because I need twice as much acid to neutralize the base. I don't know why I wrote that in this hypothetical example. So in this case, if I had worked with the acid first, I would be taking the acid amount and I would be dividing it by 2 because I need half as much base for that acid. That okay? Sydney? Does that make sense? No. So what you're thinking about is what's the ratio. So we're trying to figure out, okay, if I need this much of the acid and it says I need twice as much base, then I take whatever the number is and I times it by 2. In this example here, it says I need twice as much acid as base. So AKA I need half as much base to acid. I could also write it as 1 acid, 0.5 base, if that helps you. Yeah. Oh. If I wrote it that way and I said I need 1 acid and half as much base, then I would be multiplying by half, which is the same as dividing by 2. Oh, glue sticks? Oh, yeah. Does that make sense? Right. So that was the first question. All right. Julia, do you mind if you use yours as an example? Because yours was a good for the range and what not to do. Sorry, you're going to be the what not to do example. All right. So the next question that I got was, how do we figure out what data point to exclude? So we can see with Julia's work from question number 1, this is what you should have gotten when it comes to the tide tray volumes. And then she excluded this number here, 18.7, because it was the lowest of the numbers. And it was actually the incorrect value to exclude. And let me explain why. So if she excluded this number from her data point, she would have 19.2 as her highest, and she would have now the new low point as 18.83. So if we subtract those two numbers, the range difference in that one was 0.37, and I want the range to be within 0.3. So that was not the right number to exclude. If we excluded the 19.2, because that's my high value, then my new high value is going to be the 18.9, and my new low value, and my low value is still 18.7. So if I do the subtraction here, this difference is a range of 0.2. So that data set is the data set I would use. Does that make more sense? Julia, you were the one that made this mistake, so I'm saying, does it make sense to you now? Sort of? All right. So we just have to be mindful of which data point we're excluding. It's not always going to be the highest or always going to be the lowest. It's going to be one of those two things, and you got to figure out which is the better set. And the way you do that is you try both ends and you see which one is under 0.3. If you have both of them under 0.3, then either one would be marked as correct. So the problem with this is that because the wrong number was excluded, and then you've done the average, you're using this volume, you're actually going to get a different concentration of sodium hydroxide compared to the answer that I had. I think the answer I had was 0.126 from the top of my head. So, and that's because the wrong data number was excluded. And unfortunately, an error like that would bring you down to an achieved for this section. The reason why is because for the merit level answers, I need you to select a range of 0.3, and this is not within the range of 0.3. Yeah? The good news is you could still get merit overall on the assessment because you only need one of the two to be at merit to get merit overall. So in part C, if you did well in part C and you didn't make that mistake again, then you would be fine to still get merit. It would prevent you from getting excellence overall because with excellence you need to get both part B and part C correct. So watch out for those little things, okay? Don't make that mistake. All right, make more sense now? All right, so have some time to do some study, and then when you're ready, you can grab the part B. I will put it out so you guys can grab it. And I need the science kids to do some work. Okay. The answers to those green sheets are on my Google site, so do use that to check your work.